Hi everyone, my name is Miss G, and today we're going to be learning how to solve one-step equations. So let's go ahead and dive right in. The key idea for today's lesson is use inverse operations to isolate that variable. Now, what are our inverse operations? Simple. The inverse operation of adding is subtracting and vice versa. So the inverse operation of subtracting is to add. Let's look at one real quick example. If we have $5, right? And that would be positive 5. Even if there's no sign in front of it, we know it's positive, right? So positive $5. And then I take away those $5 from you. 5 minus 5 will cancel, leaving us with $0. So that is why the inverse operation of addition is subtraction, and the same with the inverse operation of subtraction is addition. Now, let's take a look at multiplication and division. So with multiplication and division, they have their own set of rules. Now, to cancel when we are involving multiplication and division is just think about that rule that any number divided by itself is 1. So if we see 5 in the numerator and then we divide, so we put this bar and we have a 5 also in the denominator, then this is read as 5 divided by 5. And like I just mentioned, any number divided by itself is 1. If you watch my videos, you'll see that when I divide a number by itself, I will put a straight line through them, reminding us that when you divide a number by itself, it gives you 1, and that is what causes multiplication and division to be inverses of each other. So let's try a few examples. Let's start with some simple ones when it comes to adding and subtracting. So if we have x plus 3 equals 10. We're starting with a very simple one, but our goal needs to always remain in mind. Put a line down that equal sign and find that variable, because your goal when you solve equations is always to isolate the variable. Well, I see that my variable is not by itself here. There is a plus 3 right next to it. So like we just mentioned, the inverse operation of plus is minus. So I'm going to subtract 3 so that that can cancel. Now, whatever we do on one side of the equal sign, we do on the other side of the equal sign. So I'm going to do minus 3 over here as well. Then we read from left to right. I'm going to make sure I drop down this x and bring it in a little bit. I keep my equal sign in that center, and 10 minus 3 leaves us with 7. So we know that x equals 7 in our first equation. Moving to our next one. If we have x minus 5 equals negative 18. Well, let's start with that. Line down our equal sign, box our x, and think about what operation is happening next to our x. Well, the x is getting subtracted by 5, or minus 5 is right next to it, and the inverse operation would be to add 5. When we do inverse operations, they cancel out. Whatever we do on one side, we do on the other side. We have plus 5 here. I would draw a line to organize myself. From left to right, I am going to bring down and bring in this x slightly. Keep my equal sign where that center line is. And negative 18 plus 5 gives us, well, think different signs, find the difference, so subtract, and keep the sign of the bigger number. So we get negative because 18 is bigger, and then we subtract 18 minus 5, leaves us with 13. So therefore our answer is x equals negative 13. Moving on to a few more manipulations of our equations is when we have the number before the variable. So what happens when they start changing that order on us? Well, you should stay organized and it should not throw you off. If you keep drawing that line down that equal sign and you box that variable, you are going to see that there is this 8 on the same side as that variable, and we need to move this 8 to the other side. To know how to inverse it, we just need to know what sign this 8 is. Now remember I mentioned on the last slide, if there is no sign in front of it, we know that it is positive. So since this is technically a positive 8 or a plus 8, we just don't write the sign when it's in the front, then the inverse operation would be to do minus 8 so that that can cancel. And then I go to the other side of my equal sign. I do minus 8. And from left to right, I have that x equals, well, remember, this is positive, so different, find the difference. So 8 minus 7 is 1. And keep the sign of the bigger number. 8 is bigger, so we get x equals negative 1. These problems we just did involved adding and subtracting and using inverse operations with plus and minus. Let's go ahead and try a few problems that involve inverse operations with multiplication. So, the infamous 4x equals 40. When you see that, we read it as 4x equals 40. But remember, this is actually 4 times x equals 40. When you get to algebra, whether you're in pre-algebra or algebra 1, when that number is right next to that variable, it means that they are multiplying. We don't want to write 4 times x anymore like we did in elementary school, because then that gets very confusing in high school to have the times and then the x, like which is which. Too confusing, so we nixed that. We no longer use the x to show multiplication. We use either a dot or we just write the number right next to the variable, and that shows multiplication. So let's keep on with our pattern here of writing or drawing a line down our equal sign, finding our x, putting a box around it, and I see that that 4 is multiplying to the x since they are directly next to each other. And the inverse operation of multiplication is division. In high school, we use that little line, which is the division bar or the fraction bar, to show our division. Like I mentioned on that first slide, 4 divided by 4, any number divided by itself gives us 1. You will see that I will draw a straight line down it, so I remember that. Whatever I do on one side of my equal sign, I do on the other. I will divide by 4 here as well. From left to right, I'm only left with 1x, but that 1 is invisible in front of a variable, so just x equals, and 40 divided by 4 will leave us with 10. So we get that x equals 10. Let's try another one. If we have negative 9x equals 54, well, let's keep on with our organization. We'll put that line down our equal sign, box that x. Recall that if the number is directly next to the variable, that means that they are multiplying. And the inverse operation of multiplication is division. You are going to divide by exactly what you see in front of that variable, because anything divided by itself gives you 1. And we want to figure out what 1x equals, or what that variable equals. So we are going to divide by negative 9 here. The reason that works, negative divided by negative, positive. 9 divided by 9, 1. Whatever we do on one side, we're going to do on the other side. So I am going to divide by negative 9 on that right-hand side. I end up with x, or 1x, but that 1's invisible, equals positive 54 divided by negative 9 gives us negative 6. So we get x equals negative 6. Let's try one more, and hopefully it doesn't throw you off if you're staying organized by putting that line down that equal sign and boxing your variable. So if we have 45 equals 3x, what just happened? Well, our variable is on the right-hand side, but that should not be a problem if we continue to draw a line down our equal sign, box our variable, And we see that this time, instead of the variable being on the left-hand side, our variable is on the right-hand side, and that's okay. All we have to do is make sure that that variable on the right-hand side ends up alone. And we see that a 3 is multiplying to it. So the inverse operation is to divide by 3, because 3 divided by 3 leaves us with 1. And whatever we do on one side, so therefore on this side, we did it on the right side this time, we are going to divide by 3 on the left side this time. And we end up working from left to right. So this time we do 45 divided by 3, which leaves us with 15 equals 1x, but we just write x. So 15 equals x, or x equals 15, right? This can always be written as x equals 15 in the end. That is the same thing. Let's move on to our last type of one-step equation, which is division. So like I mentioned, in high school or pre-algebra, algebra 1, you're going to see division with this little bar, which is a fraction bar, but it means division because fractions actually are division, if you didn't know that. So x divided by 6 equals -7. We're going to continue to organize ourselves, draw that line down, that equal sign, find that x, and ask yourself, what is happening to that x? Well, like I just mentioned, this line means to divide. So the inverse operation of division is multiplication. So I'm going to go ahead and multiply by 6. Remember, I said in high school, we don't use an x anymore. We'll use a dot, or we can use parentheses, but I'm going to put a little dot. 6 times 6, well, this is really 1/6. This 6 is in the numerator. This 6 is in the denominator. And any number divided by itself leaves you with 1. Whatever we do on one side, we are going to do on the other side. So we are going to multiply by 6 over here. And we end up with that x equals negative, because a negative times a positive is a negative, and 7 times 6 is 42. So we get x equals -42. Let's try another one. If we have 2/3 x equals 24. This one is a little tricky because we see that our x is getting multiplied by 2/3. So when it comes to fractions like 2/3, we need to think, what will cancel 2/3 out and leave us with 1? Because we want to find out what 1x equals. So in order to do that, we know that the inverse operation of multiplication is division, and we know the inverse operation of division is multiplication. So what this ends up doing is we're going to multiply, but what we call the reciprocal. We call this multiplying by the reciprocal. But why does this work? Remember I mentioned that anything divided by itself is 1. And if you have a 3 in the numerator and a 3 in the denominator, that cancels out to 1. And if you have a 2 in the numerator and a 2 in the denominator, that also cancels out to 1. Another way you could think about that is, how do you want it to multiply these fractions together, which is a little bit longer, but I will show it for the sake of this video. If we multiply 3 times 2, so numerator with numerator, we end up with 6 in the numerator. And then we multiply 2 times 3, so denominator with denominator, we end up with 6 in the denominator. And then you should really be able to see that where anything divided by itself gives you 1. So that is why this works. So if you end up with a fraction like 2/3 in front of a variable, just multiply by the reciprocal. It means to flip the fraction, because that will leave you with the same number divided by the same number, which gives you 1. Now, let's not forget, whatever we did on one side, we are going to do on the other side. So we are going to multiply by that reciprocal, 3/2, On the right side, we have an invisible 1 under this 24. 24 divided by 2, we can cross cancel because this is in the numerator, this is in the denominator. You can cross simplify. 24 divided by 2 leaves you with 12. 2 divided by 2 leaves you with 1. When we multiply across, 12 times 3 gives us 36. And 1 times 1 gives us 1 in the denominator. But we don't have to write that 1 in the denominator. It's invisible. So we get x equals 36. Let's try one last one. And we will have mastered one-step equations. If we have 7 equals negative x over 3. Well, let's organize ourselves. If we put a line down that equal sign, we box our x. We see that not only is that x negative, but it is getting divided by 3. And we need to leave that x with an invisible positive 1 in front of it. So the inverse operation of division is to multiply. But I'm going to multiply by negative 3 because 3 in the numerator and 3 in the denominator will cancel. Right? Because anything divided by itself is 1. But negative times negative will give you positive. And we want that x to be positive in the end. So what we are going to multiply on our left side is also negative 3. We work from left to right. So negative 3 times 7 leaves us with negative 21. And that x is by itself. So negative 21 equals x. I hope that you guys enjoyed this video and were truly able to understand how to solve one-step equations. Just remember to keep yourselves organized. Draw that line down that equal sign. Find that x because your goal is to have that x or that variable isolated, and then always ask yourself, what operation is happening to that variable and how can I inverse it? And whatever I do to inverse it, I do it on both sides of the equal sign to keep it balanced. Again, thank you so much for watching my video today. I hope that it was able to help you. If you have any further questions, please leave your questions in the comments and I promise to get back to you. Also, don't forget to like and subscribe. Have a great day, guys. Bye.